For our ME102B class, we designed a window cleaning device. We set out to work on this because cleaning skyscraper windows are a very dangerous task. In fact, the Sears Tower in Chicago uses robots to clean its windows for this exact reason. We wanted to try our own iteration of a scaled-down window cleaning robot that could be applied to a similar use case as skyscrapers. The device features a cleaning box that's moved vertically and horizontally along the window, and it cleans using an electric spray bottle and foam rollers. The electronics are connected using Ethernet wires to a breadboard and an Arduino on a table. There is an ultrasonic sensor to detect window barriers and the ground, a push button to start up the device, a vertical limit switch to stop the winch from rolling up, a motor encoder to keep track of the vertical position, and a horizontal limit switch to reset the stepper motor. The stepper motor controls horizontal position and moves in conjunction with a belt and pulley system. The belt is tightened at the very edge on the end plate. Here we see the bottom foam rollers rotating. They're also powered with a belt drive using a DC motor on the inside of the box. There are also two brushless motors with propellers on the bottom. They provide the lateral thrust to keep the cleaner on and off the window. The bottom sprayer uses a peristaltic pump to spray the water from a tank. Unfortunately, it broke during our testing. A subsystem that we're especially proud of is the winch that attaches to the motor. The ends were turned on a lathe and milled flat. The winch required precise tolerancing to place the 3D printed spools and the bearings on the edges. The part used a combination of 3D printing, milling, using a lathe, and laser cutting the housing. It also worked great with the motor's PI controller that maintained the angular velocity. After the push button is pressed, the box moves up until it hits the vertical limit switch. It then moves to the side until it reaches the horizontal limit switch. Then it runs the foam rollers and propellers to clean the glass. An issue that can be seen here is a poorly soldered foam roller connection, which prevented them from briefly running. On the way up, the propellers and foam rollers are turned off as it cleans only on the way down. To speed things up, I ran this clip on double speed. Once it reaches the edge of the window, it stops, and it'll restart the process if the push button is pressed again. One issue we had was the tilting of the cleaner box. We used screws on the side to stabilize it and found that symmetrically wrapping the string could eliminate this issue. We also had an issue with the vertical limit switch delaying the winch from stopping. You'll notice here that the stepper motor runs even when it's still going up. This is why we had to manually press the vertical limit switch ourselves. So thank you for checking out our project. We had a great time working on it and learned an incredible amount doing so.